So this whole exercise is related to questions related to chemical energetics from Unit 2 topic. So the first question, which equation represent the standard enthalpy change of formation? So the definition for standard enthalpy change of formation is that when elements in the standard form form 1 mole of a compound, we call that as standard enthalpy change of formation. So we have the elements here because the element hydrogen is reacting with iodine to form hydrogen iodide. So element in the standard state, hydrogen at room temperature, it is a gas, so hydrogen should be a gas. And iodine at room temperature, it is solid, so it should be solid and forming hydrogen iodide, which is also in a gaseous state. Then the equation must be balanced. Here we have one iodine because the condition is that for standard enthalpy change of formation, that 1 mole of a compound is formed. But here when we check the equations, equation B and equation D, in equation B we have 2 moles of hydrogen iodide, but in equation D we have only 1 mole of hydrogen iodide formed from the elements in the standard state, like hydrogen in a gaseous state and iodine in a solid state. That is why option D is the right answer. Is it clear? Moving on to the next question, question 2. When 50 cm cube of hydrochloric acid, concentration 2 mole per dm cube, is added to 50 cm cube of sodium hydroxide of concentration 2 mole per dm cube, the temperature increased by 13. The equation is given for reaction between hydrochloric acid and sodium hydroxide, which result in a formation of sodium chloride and water. The experiment is repeated using 25 cm cube of hydrochloric acid and 50 cm cube of sodium hydroxide. What is the temperature increase or what is the temperature change? So how we can relate the enthalpy change or the energy change with mass and temperature? So we have the formula that E is equals to Cm delta T. Or if we make a subject, delta T is our subject, so we change the equation, so it will be E divided by Cm is equals to delta T. So what this equation shows that the temperature change is directly proportional to energy release or the number of the moles, because greater the number of the moles, greater the energy release. And it shows that temperature change is inversely proportional to mass or the volume of solution. As for these type of questions, we consider that the density of the solution is 1 gram per cm cube, so the mass is same as the volume. Now originally, how many moles are there? As we know, the ratio is 1:1 between sodium hydroxide and hydrochloric acid. So initially, how many moles of sodium hydroxide and hydrochloric acid are reacting? 50 cm cube. So we divide by 1000, so it will be 0.05. And the concentration is given 2. So moles equal concentration into volume. So the concentration is 2 and the volume is 0.05. So it will be 0.1 mole. So initially, we are using 0.1 mole of hydrochloric acid. But then we change the experiment. We are using 25 cm cube of same concentration. So 25 cm cube means 0.025. That's the volume. And to get the moles of hydrochloric acid, initially we use 0.1 mole. But now with the same concentration is given 2. So 2 multiplied by 0.025. So we are using 0.05 moles. So originally we were using 0.1 moles of hydrochloric acid, but now we are using 0.05 moles. So it means the moles is half, so energy release will be half. So this, if energy release is half, the temperature change will be half. That is first thing. Now what about the volume? The total volume of the solution, the total volume in the beginning we used 50 cm cube of hydrochloric acid and it was mixed with 50 cm cube of sodium hydroxide. So in the first experiment we used 100 cm cube of the solution, the total volume. But in the second experiment we used 25 cm cube of sodium hydroxide and 50 cm cube. So we are using only 75 cm cube of the total solution. So what is the change here? So what is the change in the volume? Originally, if we are using 100, but now we are using only 0.75, 75. So 100 divided by 75. So the volume is changed by 1.33. That is the decrease in volume, because 100 divided by 1.33, you will get approximately 75. So means the volume is decreased by 1.33. And what is the relation between the volume or the mass and temperature change? They're inversely proportional. So the volume or the mass is decreased by 1.33. So the temperature change will increase by 1.33. So what is the overall change in temperature? So due to the change in the number of the moles, it was divided by 2. And due to the change in volume, it is multiplied by 1.33. So original temperature change was 13. So 13 multiplied by 1.33, and that is divided by 2. The original temperature change is 13. That's delta T. So this is 13 multiplied by 1.33 divided by 2. So we'll get as 8.64. So which is equal to approximately 8.7 degree centigrade. Is it clear? Discussion? So simply you relate the temperature change proportional to energy release or the number of moles, and temperature change is inversely proportional to volume or the mass. So mass was changed by 1.33, decreased by 1.33, so temperature change multiplied by 1.33. And the number of the moles are divided by 2, so temperature change should also be divided by 2. So simply the temperature change should be divided by 2 and multiplied by 1.33, and this was 13, so we got 8.7. Moving on to the next question. Nitrogen react with hydrogen to form ammonia. What is the mean bond in kilojoule per mole for NH? The enthalpy change for this question is given. So first we write in terms of bonds, we will write the equation. So now N2 means nitrogen triple bonded with nitrogen. Then H2 means hydrogen single bonded with hydrogen, and how many of them are? 3. So there are 3 molecules of hydrogen, and it gives 2 molecules of ammonia. And the energy change when this reaction occurs, the energy release at forward reaction is exothermic, as it shows that minus 92 kilojoule per mole of energy is released. So simply the formula is bond breaking minus bond forming is equals to energy change. So bond breaking, I'm writing in short BB, that's a bond breaking. So what are the bonds we are breaking? Nitrogen, nitrogen triple bond is there, and 3 of the hydrogen, hydrogen single bond. So this will be 945 plus 3 times 436. That's a bond breaking. Then bond forming, the bonds which are formed, NH bonds are formed 1, 2, 3, 4, 5 and 6. So there are 6 NH bonds are formed that we are finding. And the formula which relate this bond breaking minus bond forming is equals to energy change, and the forward reaction is exothermic. So we will substitute in the formula that bond breaking minus bond forming is equals to enthalpy change or energy change. So bond breaking was 945 plus 3 times 436 minus the bond forming is 6 times the NH bond, and we are finding for each only, and the enthalpy change is minus 92 kilojoule per mole. So we only need NH, the energy for NH bond. So it will come out after solving this. This 945 will move to other side. So it will come out as 391 kilojoule per mole. That is a bond energy for NH. Simply we have to move this 945 other side, 3 times 436 other side, and then the 6 is multiplied, will divide. So our final answer will be 391 kilojoule per mole. Moving on to the next question. How many moles of carbon dioxide are formed when 3 moles of chloroethane ethene is mixed with 10 moles of oxygen and react as shown? So first we should know the limiting reagent, because from limiting reagent we can work out the amount of the product. So how we can work out the limiting reagent? The simplest ratio between chloroethene and oxygen is 2:5. If we have 3 moles of chloroethene, then how many moles of oxygen are needed? X, cross multiply. So it will be 3 multiplied by 515, and that divided by 2, that's equal to 7.5. So we need 7.5 moles of oxygen for a complete reaction. But how many moles we have? We have 10 moles, so it means oxygen is more than what we need, or oxygen is in excess, or chloroethane is a limiting reagent. So whenever we find the product, we always use the limiting reagent. So now we'll use the ratio of limiting reagent, which is chloroethene to carbon dioxide. The ratio is 2:4 or 1:2. So if we have 3 moles, this will be X. Cross multiply 3 multiplied by 4, that's 12 divided by 2, equal to 6 moles of carbon dioxide will be produced. So C is the right answer for this question. So whenever both reactants are given, we always use the limiting reagent. So first step should be finding the limiting reagent, and from limiting reagent you will find the desired product. This is a structure question related to chemical energetics. This question is about hydrated salts. Enthalpy change for conversion of anhydrous copper to sulfate to hydrated copper to sulfate can be found by using Hess law. A student carried out experiments to determine the value of enthalpy change. Known masses of anhydrous and hydrated copper to sulfate were dissolved separately in an insulated container, and the temperature change measured. The temperature change is measured. The results are shown in the table. So the first question, explain why different volume of water are used into experiment and justify your answer. So why we use, like here we use 45.5 and here we use 50. So what could be a reason why we have different volumes here? So basically you can see here hydrated crystals have already water. As you can see, CuSO4.5H2O, and anhydrous does not have any water. So why we use different volume of the water for use into experiments? Because hydrated crystals already contain, or hydrated salts already contain water, so that the total amount or volume of the water kept same. As you can see, the total volume or the mass or the amount of the water will be same. That's why in a hydrated crystal we use only 45.5, but in anhydrous we use 50 cm cube, so that when we get the total it will come out as 58 grams of each salt. Next question, calculate the enthalpy change for solution in kilojoule per mole for anhydrous. Assume that the specific heat capacity of a solution is 4.2 and density of a solution is 1 gram. So when they say density of a solution is 1 gram, so we can consider the volume and the mass have the same value. So enthalpy change, the formula for enthalpy change, E is equals to Cm delta T. So specific heat is given 4.2. But what about the mass? The mass of a solution is same as the volume of the solution. And what is the volume of solution used for anhydrous? We use 50. That's why the mass is 50. And the temperature change here, that's 16. So that is equals to 16. This will give answer in joules because the specific heat is in joule per gram. So this, our answer will be in joules, which is 3360 joules. But we should always convert this answer into kilojoule. So to get the answer in kilojoule, we'll divide by 1000. So it will be 3.36 kilojoule. But we need enthalpy change. Enthalpy change is kilojoule per mole. So what about the moles? The formula for moles, moles equal mass in gram divided by molar mass. So we have the mass in gram, that's 8. And what about the molar mass? Molar mass of copper sulfate, how we can work out? Because we need enthalpy change. So enthalpy change or delta H is equals to energy per mole. So E divided by N or E divided by mole. So how to get the moles? We have the mass in gram divided by molar mass. So copper is 64 plus sulfur is 32 plus oxygen is 16 times 4. So this will give us the moles of anhydrous copper sulfate. So 8 divided by approximately 159.5 or 160, you can also say. So we'll get the mole 0.0501. So these are the moles of copper sulfate, but we need enthalpy change. So enthalpy change is energy divided by mole, so 3.36 kilojoule divided by mole 0.05. So we'll get enthalpy change as 67 kilojoule per mole. This will be the enthalpy of solution. And here the temperature change is given plus 16. So what is the meaning of plus 16? It means the temperature difference of final temperature is higher than the initial temperature. So it means this reaction is exothermic. So how we represent the enthalpy change for exothermic? So it should be negative value. So here we should write minus 69 kilojoule per mole. If the reaction was endothermic, the temperature decrease because the temperature change is final minus initial. So if you are getting a positive temperature change, it means the final temperature is higher and initial temperature is lower, or the reaction is exo. And so if delta T or change in temperature is positive, it means it is exothermic reaction. If change in temperature is negative, it means it is an endothermic reaction. So this was 69 kilojoule per mole. Complete the Hess cycle by adding two arrow heads. So how we represent a Hess cycle and the two arrowheads, which direction we should show? So here, because the overall energy change is independent of the route or the path which we follow. So complete the Hess by adding two arrows. So what happened? If we have anhydrous copper sulfate, we add water, so it will become aqueous copper sulfate. Or if we have hydrated copper sulfate and we add water, so it will also form aqueous copper sulfate. So the both arrows should point outward. And overall energy change is independent of the route. So they ask in the next part, they ask calculate the value of enthalpy change for enthalpy of reaction in kilojoule per mole for conversion of the anhydrous to hydrated. So this is unknown, this is X. What about when hydrated anhydrous copper sulfate we add water? So this we already worked out. That was 69 kilojoule per mole negative. Our previous answer 67, sorry, not 69. So this was 67 minus 67 kilojoule per mole. And this value is given 12.6 kilojoule per mole, and we are finding this part. So overall energy change is independent of the route or the path which we follow. Where the two arrows are pointing out, that is the start of the cycle. So here the two arrows are pointing out, so that is the start of the cycle. And where the two arrows are pointing in, that is the end of the cycle. So we can write the equation, we can write enthalpy of the reaction plus 12.6 equal to, because this is route 1 or the path 1 and this one is route 2, is equals to minus 67. So this is 12.6, it will move to other side. So minus 67 minus 12.6. So it will be 69.6 kilojoule per mole, and a negative answer. So enthalpy will be minus 69.2 kilojoule per mole. That is the overall in not 69, 79 basically, because it is 67 and then 12.6. I thought it was 2.6, but that's 12.6, so it will come out as 79.6 kilojoule per mole. Moving on to the next question. Hydrates of sodium carbonate may be represented by a formula Na2CO3 dot XH2O. The value of X can be found by making up a solution of sodium carbonate and titrating with a solution of hydrochloric acid of known concentration. A known mass of sodium carbonate was dissolved in water and made up to a mark 250 cm3, and 25 cm3 portion of was titrated with 0.09 mole per dm3 hydrochloric acid using methyl orange as an indicator. The mean titer was 25.6. The equation for neutralization of sodium carbonate to hydrochloric acid is given. Calculate the amount in moles for sodium carbonate in 25 cm3. So first we have the concentration and we have the volume of hydrochloric acid. So using a concentration and the volume, but the volume should be in dm cube, so we divide by 1000. So it will be 0.0256, that's dm cube. So you first concentration into volume will get the moles of HCl. Using a mole ratio will get the moles of sodium carbonate, but that moles will be in 25 cm cube. In 250 cm cube the moles will be 10 times because the volume is 10 times. So the solution for this, so step by step. So the first part, it is moles of HCl, that is concentration into volume, 0.09 times 0.0256. So this will give us the moles, 0.09 times 0.0256, that's equal to 0.00223. These are the moles of HCl, but HCl to sodium carbonate, the simplest ratio is 2 is to 1. So if we have 0.0023, this will be x cross multiply. So we'll get the moles 0.0023 divided by 2. So we'll get the moles 0.001152. But these are the moles in 25 cm cube of solution which we titrated, but original solution was 250 we made in a volumetric flask. So in 250 cm cube, because the volume is 10 times, so moles will also be 10 times. So this will be multiplied by 10. So our final answer will be 0.01152 moles of sodium carbonate in 250 cm cube solution. Moving on to the next question. 250 cm cube solution was prepared by dissolving 3.29 grams of sodium carbonate. Use this mass and your answer to D1, the answer to D1 which we already solved, the moles of sodium carbonate. Appropriate number of significant figure, determine the value of x. So how we can find the value of x? So we already worked out the moles which were 0.01152 moles of sodium carbonate. In the last part, so 0.01152 are the moles of sodium carbonate. Now using these moles, first we'll find the mass of sodium carbonate which was there in the solution, because they mentioned we took the total mass. This was the total mass of hydrated sodium carbonate. So first what we'll do, we'll find the mass of sodium carbonate in it. So to get the mass of sodium carbonate, we have the moles and we have the molar mass of sodium carbonate. Mass of only Na2CO3 or sodium carbonate is equals to moles multiplied by molar mass. So the moles which we use here, that is 0.01152 0.1152. And the molar mass of sodium carbonate, how to work out the molar mass of sodium carbonate, because sodium is there, which is 23 using a periodic table, multiplied by 2, plus carbon is 12, plus oxygen is 16 multiplied by 3. So this multiplication will give us actual mass of sodium carbonate, which will come out as 1.221 grams. Now to get the mass of water of crystallization, so hydrated, basically the hydrated salt minus the anhydrous will get the mass of the water. So mass of hydrated, in the question it is given 3.29 minus mass of anhydrous, that is 1.22. So this will give us the mass of water at 2.06 grams. Then moles of the water, moles equal mass in gram over molar mass, so 2.06 divided by molar mass of water. Hydrogen is 1 multiplied by 2 plus oxygen is 16. So the molar mass is 18. This will be 0.1149. Then the ratio, because we need how many, what is the value of x? X is a mole ratio. So what is the simplest ratios? The moles of the sodium carbonate were 0.01152, and the moles of the water which were used here 0.1149. So when we take a simplest ratio, we divide by the smallest value. So when you divide by the smallest value, the ratio, it will come out as 1 is to 9.98 or approximately 10. So simplest ratio is 1 is to 10. So if we have 1 mole of sodium carbonate, we will have x moles of 10 moles of water. So what is the value of x? The value of x is equals to 10. In question 6, the bond enthalpy for chlorine-chlorine bond is 243 kilojoule per mole. What is the enthalpy change of atomization of chlorine? So when we write this equation, it means like when we have chlorine molecule, it will we break the bond and form chlorine atoms in a gaseous state. The enthalpy change here is 243. But enthalpy change of atomization means when we produce 1 mole of chlorine atom in a gaseous state. So if we are producing 2 moles, the energy change was 243. But if you are producing 1 mole or half mole, compared to the first value, it is half. So the enthalpy change value will also be half. So half of 243 is 121.5. So C is the right answer. And it should be a positive value. Why it will be a positive value? Because atomization is an endothermic. That's why it is a positive value. In question 7, the standard enthalpy change of neutralization for reaction between sodium hydroxide and hydrochloric acid is minus. So it means the reaction is exothermic. So either A will be answer or B. And for exothermic reactions, what happens? The temperature rise or increase, so it will be A. Question 8. The diagram shows a reaction profile for a reversible reaction. Reversible reaction means reactant can form a product and a product can decompose and form back the reactant. Which symbol represent the enthalpy change of a reaction from R to P? So if we have this as a reactant and this is a product, we need enthalpy change. Enthalpy change is actually a difference in the energy between the reactant and product. And because this reaction is endothermic, basically the energy change is given by either V or X. But why V is the right answer? Because this reaction is endothermic, so endothermic reaction, the enthalpy change is positive, so the arrow must point upward. That's why B is the right answer for question 8 part A. If it was an exothermic reaction, like the same reaction was there, but reactant have a high energy and product is having low energy, so the arrow must point downwards. In that case, X will be the right answer. But because this is an endothermic reaction in terms of R to P, so enthalpy change should be positive, or B is the right answer. The second part, which symbol represent the activation energy? Activation energy is minimum possible energy for the reaction to start, and they are asking activation energy from P to R. So now P is our reactant and R is our product. So energy from reactant till the start of the reaction, that's called activation energy. So in that case, W is the right answer. So C is the right answer. The Hess law can be applied to the system. Which expression is correct? So which of the expression is represented correctly? So when we check all the options, V plus X is equals to U plus V. V plus X is equals to U plus V. That's wrong, because when you add the energies for, so V plus X is not equal to V plus U, or V plus X is not equal to U plus W, because U plus W is different value and V plus X is same. The second option, W plus X is equals to U. When you add W with X, that is equals to U. That's also wrong. Why it is wrong? Because W is pointing up, X is pointing down, and that the sum cannot be equal to U, because one of the value will be positive, another value will be negative. And U minus W is equals to V. So that's right, because U is pointing up, W is pointing up, and when we subtract them, that will be equal to V, so endothermic. So C is the right answer for question 8. So these are the questions from chemical energetics. Next session we will continue this discussion and discuss more questions from unit 2 topic chemical energetics. Any question related to the class today?